Part of air conditioning is knowing about motors. Motors drive every part of the process from the compression refrigeration cycle through the movement of the air around the building and through the rejection of the heat outside. Everything having to do with air conditioning involves motors. So understanding the different types of motors you encounter is probably pretty important. That's what this lesson's about. So when we go down the list of the different motors, we see a shaded pole motor, which you can always tell because it's a very small motor. It has a single run winding. Then we start getting into the split phase motors where we have a start and a run winding and some type of switching. Again, I'm going to say some type of switching to remove the start winding from the motor circuit once the run winding is up to speed, and that's putting it simply. Then we also have a capacitor start induction run known as a CSCR motor. Again, the start capacitor and the start winding come out of the circuit once the motor reaches a certain speed. Then we have a PSC for permanent split capacitor. In this motor, the start winding and the run capacitor are always in the circuit. Then we also have our split phase that uses a centrifugal switch. Again, start winding comes out of the circuit once the motor reaches a speed. We have a split phase with a current sensing relay. Again, start winding comes out of the motor. We'll talk much more about these start relays as we go on. We have a split phase with a solid state relay. We have a capacitor start induction run with a centrifugal switch. Again, there is a start capacitor in here with a switch that takes the start winding out of the circuit. We have the same motor with a current sensing relay. Then we have that same motor with a potential relay. Okay, and then with a solid state relay. Again, all these different start components, all they do is remove the start capacitor and the start winding from the circuit once the motor starts to spin, and it's usually about 75% of its speed. And there's just more motors as we go on through here with different components. We have a permanent split capacitor. That one always stays in the circuit. Induction start, capacitor run. Okay, so in this case we have the start winding, okay, comes out of the circuit once the direct link to the start winding comes out of the circuit once the motor starts running. And then after that, the capacitor. Okay, you don't see this very often. Capacitor start, capacitor run. CSCR motor. This you see pretty often in, especially when there's a hard start kit involved. That's exactly what we add. We add the capacitor start with the switching. And then in blower motors, we a lot of times see multiple speeds. You have a high, medium, low, and low speed taps. Okay, motor start windings are smaller diameter wires. They have a higher resistance. They have a stronger magnetic field to get the motor to start turning. However, they must be removed from the circuit as quickly as possible or protected from excess current if they're left in the circuit. This is known as the phase winding. The winding all capacitors connect to is the start winding. The motor run windings, large diameter wire, less resistance than the start windings. They're not removed from the electrical circuit. They're not protected from excess current, and they're sometimes known as the main winding. The run winding always has to have power if you expect the motor to run. The shaded pole motor is a single speed or multi-speed, low running and low starting torque. In other words, it cannot drive much weight. It can't have much force on it. It has a run winding only. This is an example of a shaded pole motor. Very small motor. Sometimes what you usually see in small evaporator fans, more on the refrigeration side than the air conditioning. Sometimes they are in window units. Okay, the wiring diagram is easy. One run winding. The split phase motor has both a start and run winding. Start winding must be protected. A start relay removes the start winding from the circuit. once the motor's turning. A low starting and low running torque. Again, can't drive much weight. You see plain split phase motors in things like dishwashers, dryers. You don't often see them any in air conditioning. And again, you have a start switch, red over here, that takes the motor out of the circuit once, or it takes the start winding out of the circuit once the motor starts to run. And this is an example of a diagram. Okay, run winding is small, start winding is a little bit longer, has a switch. This can be drawn in many different ways. Capacitor start induction run, CSIR motor, is not common motor for AC units. It's more used in refrigeration on the compressor side. It has a centrifugal switch or start relay to remove the start capacitor and start winding from the circuit once the motor reaches about 75% of its RPMs. It's an open type fan motor, will have a centrifugal switch. Compressor will have a relay. PSC is a permanent split capacitor motor. Okay, it's a split phase motor with a run capacitor only. The run capacitor is wired in series with the start winding. There's no start relay or centrifugal switch needed. The run capacitor reduces the current flow through the start winding. Having the start winding in the circuit gives the motor good running torque. Can drive a slightly heavier load with this. This is a very popular motor for both compressors and for blower motors and for outdoor fan motors. So again, we have our run capacitor with the start winding. That run capacitor is in series with the start winding. Okay, if you take a look at how we're powering this, we power the run terminal, we put the run capacitor between the R and the S, and then we power again on common with line voltage. Run capacitor is in series with the start winding. CSCR is capacitor start, or CSIR, that should say, is capacitor start induction run. Okay. Basically, it's a PSC motor with a start capacitor and a relay to drop out the start cap. It has a high starting torque. Hard start kit is often installed on a PSC motor if it has difficulty starting. Again, CSCR, capacitor start, capacitor run. Okay, high starting torque, hard start kit, and this actually should, this up here should be capacitor run. Hard start kit is often installed on a PSC motor, and if we take a look at the wiring diagrams, and I'll show you that in a minute, you will see that. Motor bearings, bearing type is determined by a load and acceptable noise levels. Sleeve bearings are used on light loads and have low noise levels. They're lubricated with oil. Ball bearings are noisier than sleeve bearings, and they're usually lubricated with grease. Okay, so again, sleeve bearings are sort of a sleeve that fits on top of the motor shaft, has an oil port on it. Important that they be oiled properly because there are no ball bearings in these. Motor mounting types determine how a motor will be secured during operation. Rigid motor mount, it's bolted to the frame of a fan or pump. Resilient or rubber mounts reduce motor noise. Cradle mounts, motor sits in a cradle. Rigid base mounts, the base is mounted to the motor. End mount, it's used on small motors, it mounts from the end. A belly band or strap mount, the strap wraps around the motor and holds it steady. Motor drives are two different ways basically. Direct drive, the motor shaft is connected directly to the load. The load turns at the same speed as the motor. You see this in most residential and light commercial air handlers. Belt driven, uses V-belts and pulleys. Load can rotate at different speeds from the motor. You see this in most rooftop units. It's very important. The drive and the driven pulleys must be perfectly aligned. You can't have any side-to-side movement on this, and they have to be in perfect alignment or the belts will wear out extremely fast. Okay, this is an example of a PSC motor with multiple speed taps. Okay, we have our start winding here. We have our run capacitor that's in series with the start winding. Start winding is in parallel with the run winding. You have different speed taps, low, medium, and high. And then again, we do need to, I did want to go back and repoint out the CSCR motor type because this is sort of important. Okay, this is a capacitor start, capacitor run wind motor. Okay, again, we have our start cap that's here. Okay, let me just okay, we have our start cap. We have our switch sting device that takes the start cap out of the circuit, and then we have our run cap. So when the motor's starting, this switching device is closed and allows current to pass through the start cap to the start winding. Then as soon as the motor reaches 75% of its speed, that switch opens and allows just the current to pass through the run capacitor. So knowing these different types of motors is pretty important, and you just want to make sure you're aware of them as we go through the rest of this course.